Hello students, welcome to the IMS Gate Academy. So now let's begin this session on computer networks, which is part of the Gate course booster session. So from the series of this Gate course booster session, successfully we have done the two subjects in computer science branch, that is operating system we have done, that is into two sessions and followed by computer organization architecture. So as part of this series, now in this session we will discuss on computer networks. Again, as I told you earlier also, we will take up some important questions, like the important area from the computer networks we will discuss. So and also we will observe the important points and formulas which are related to this the topics we will observe in this session. Just before starting up the system, starting up this session, just confirm me all of you, my voice is clear. So shall we start the session, all of you. So I hope everything is clear. So come to the point what I am going to discuss in this session, like the first area, you need to be focused also. You have to emphasize on your revision, like emphasize your revision on these are the topics majorly. IP addressing system, so especially you need to focus on classful IP address as well as classless, subnetting and supernetting process. Coming into the flow control, various flow control mechanisms you might have studied, especially like a stop and wait protocol, go back and SR protocol, GBN SR protocol majorly. From error control, there are two things we have, error detection and error correction. From error detection, you understand CRC and checks on this various things also there, but just majorly focus on the CRC, asked Hamming code, like of Hamming codes, especially you should know about finding the Hamming distance. Hamming distance for the detection, bits detection as well as the bit correction also, that need to be focus. So coming into this access control methods, random access control methods and access control methods. One is Aloha, but very rarely ask the questions from Aloha, but still need to be studied this Aloha. And some properties of CSMA, and CSMA CD is much important because basically it is used in Ethernet. Okay, Ethernet, CSMA CD used Ethernet. As well as one more access control method is token passing mechanism. So token passing. So especially it is used in token ring. Token ring is a one of the LAN technology, you understand. So I mentioned LAN technology focus on Ethernet and token ring, and a very straightforward questions can be seen in a token ring, and Ethernet a little related to this CSMA CD, they can frame a question including like this. Even like if you take CSMA, one persistent mechanism that is used in so Ethernet only, correct or not. So coming into the switching, so this is part of you understand, from the flow control, this error control and data link layer, access control, this all comes under data link layer only now. So this part is from network layer, and switching also network layer, IP also network layer, because the computer network can be study, you can study from top to bottom, you study complete application layers thing, then comes down to like transport layer, data link layer, network layer, physical layer, the one way of studying. The other way you start completely study on physical layer, then data link layer, network layer and transport layer, some points related to what presentation session layer and application layer protocols. So as part of the computer networks, we less focus on physical layer, majorly focused on data link layer and the network and transport layer. Three are peak layers which you have to study from the course of computer networks. Okay. So now coming to the point, like as I told you, this part from year to year it is completely covered on data link layer, and switching and IP, this IP address system also part of the network layer. Okay. Switching is one is datagram, like circuit switching is a packet switching. The packet switching is much important. Okay, many times the questions are framed in packet switching. So we use the concept of packetization. So very good evening JP and Tirumala Reddy. I hope everything is clear. So just follow the point session. Now coming into the IP, especially you should focus more on IP header format, so all the header part of the IP, as well as fragmentation. It is also important topic, you understand now. Generally fragmentation we perform on routers, intermediate routers, okay, because we do the segmentation at a source, the fragmentation we do at what you can say at routers in a network, okay. These are the things need to be covered, followed by some protocols, network layer protocols, but we support for data link layer also. They give a like a service to data link layer, like address resolution protocol, reverse address resolution protocol, BOOTP, DHCP and ICMP. ICMP packet is very much important, very much important. It has a lot of roles, especially two category things can be used. One is error reporting the source, as well as getting some information, debugging the network also can use ICMP packet can be generated by the source. Coming into transport layer, majorly two important protocol from the transport layer we have. So that is a TCP as well as UDP. So especially in this case, from TCP IP point of view, you need to focus on wraparound time calculation, okay. The followed by this is what TCP state transition diagram. TCP state transition diagram, okay. You must study the connection, basically TCP is a connection oriented protocol, having the three things always: connection establishment phase and data transmission phase and termination phase. So this establishment, data transmission, termination can be properly seen through what? Process state transition diagram of the TCP, that need to be observed here. So related theoretical questions many times asked in this area. And one important thing, congestion control. Generally you understand flow control mechanisms, various flow control mechanisms you study from here, right? GBN and SR protocol, okay. This flow control, the sliding window protocol applications you can see in a data link layer as well as in network layer. Data link layer as well as not network layer, data link layer as well as a transport layer, transport layer. Because TCP always take care of the end-to-end transmission, right, end-to-end delivery, right. So it is guarantee the delivery, okay. So therefore we need what you can say, we implement through various flow control. And also the flow control always talk about what is the receiver capacity, now how much sender has to send, before getting an acknowledgement from the receiver, or it is always sender is sending the data, depends on the receiver capacity only. Receiver capacity sender come to know through advertised window, right? Am I right, all of you, those who are watching? Advertised window we have, through which advertised window a sender can able to understand the capacity of the receiver. But the difficulty part is that sender will not able to know, there are no any mechanisms to know, identify the exactly capacity of the network which can hold it. So many times what you can say, due to this heavy traffic in the over network, packets are dropped. So packets are dropped at routers, correct or not? Now congestion control is a mechanism to know, not only you should know about the capacity of the receiver, you should know the capacity of the network, based on that only should send it, because TCP packets are, we should provide the reliability. So it should not be packet should not lose at network, correct or not? That is the reason various algorithms we have, like a slow start phase and congestion avoidance phase and detection. Through detections also we can retransmit, right? So those things we need to be focused, much important. This is much important topic we can tell now, okay. So as well as you have to also study one is error control mechanism also, okay. Error control in TCP, example retransmission, how you do it. So when it comes to application layer, focus on DNS, because theoretical questions can be expected, and HTTP. These all are one of the protocol compulsory comes in a gate paper. Every gate paper you can see some questions will be there. So here we can expect 1 to 2 marks possible, 1 to 2 marks possible from application layer. The last one is important. So sometimes a couple of times asked the question, network address translation, like a private network and public networks, like you suppose you understand now, point you have to understand now. So private IP address is there which we are using. I want to connect to what this one like this, public IP, this is ISP. Okay, this is private network. So private network, this address translation will be there like this from year to year. Network address translation, this also try to study a few things on this one, because 2024 there was a question also in this network address translation. Okay. So these are the essential topics you need to be focused on. Okay. From chapter 1, IP addressing system, in majorly classful addressing as well as classless and subnetting and supernetting, try to study. I will see also some questions based on this. Okay. We'll solve some questions. Okay. Come to the point here. I hope this is clear. The major topics need to be focused from IP addressing system. Classful IP address system, like this has a class A category, class B and class C. Okay, majorly IP addresses we have. DE also there, but this is a public IPs we have. Classless inter-domain routing, subnetting classful as well as subnetting classless, supernetting classful, supernetting in classless also. So need to be observed. Yes, yes. Okay. Now come to the point, just quickly try to answer some initially easy questions, very easy questions. I hope you can be able to answer it. Answer this question now, all of you. Those who are watching, answer this question. Which of the following is the last IP address, okay, IP address of class B, so which can be assigned to a host, which can be assigned to host. So Pardasarathi 16-bit host ID, 16-bit network ID. So Vinay saying C and JP saying C, Pardasarathi saying D. So as we know, class A, okay, in a class A, if you take class A, we have a network ID, okay. This entire IP address system divided into two parts, correct or not? Network ID, host ID. For network ID, we have 8-bit and 24 bits are there. Out of bit, anyway, 1 bit is reserved. So this all the information you know, right? So when it comes to class B, okay, again network ID portion we have and host ID portion we have, correct or not? Network ID having 16-bit and this also having 16-bit. Out of 2 bits are reserved. So out of 2 bits are reserved to define whether this class B or not. Then 14 bits are available. 2 power 14 network possible in class B. Now 2 power 16 minus 2, because all host, all zeros combination, all ones combination need to be ruled out or not. So these rules already you know these things. So try to revise properly. So number of networks possible how many? 2 power 14, correct? So number of hosts possible 2 power 16 minus 2. I hope it is clear. Why minus 2? Because in a class B or A or C, all zeros either in network ID or host ID is reserved. And all ones in the network ID or host ID also reserved, correct or not? These two numbers need to be removed. So in this network portion, you will be not getting any all zeros concept. Some ones are that is a full bits I can utilize it. Here it's not possible. Now what is the question? So ruled out, where all zeros all ones ruled out. All zeros all ones ruled out means can I eliminate this one? Option D, can I eliminate it? So option B also can I eliminate or not? Yes or no? See, just knowing some basic information, we are able to remove it, correct or not now? So means all zeros, all ones. So except all ones means for 254 available. Now how to see class B? First 2 octet defines the what network. Next to octet defines host part. So now highest to host now see. So this is 3 are there. This is talking about, this is related to class C, correct or not? It is related to class C. This is related to now class B, correct or not? Class B. So they are asking class B only, right? Yes, we can answer class B, correct? X-Fire network portion, this is host all combinations, you can see at last host will be this one, right? So can you answer me all network are either host, all zeros, all ones, all zeros combination, where I can use this one? This one. where we can use this IP address now, because you told like all zeros all ones are reserved. If I make it all zeros all ones, all zeros combination, where we can use? Sir, if all zeros in host ID is a network ID of network, very good. All ones in the host, all ones in the host ID is a DB of network, very good, very good. If all zeros, if all zeros are there like this, so including network and host, all zeros are there now. This is the first IP address or not? Am I right? This is the first IP address among 32-bit IP address system. First IP address, first number, first address, isn't it? If all 32-bit are 0, first number only, first number or first IP address. Yes, 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 yes. Somebody tell me. What is this value? This one. Default root. What is the default root? No. So default root. So router sending 0.00, one of the root is default root. So meaning do have IP address for that. So one application, if you observe, you understand, whenever host do not have IP address, simply is using as a source IP address. We can use this as source IP address. Send a packet to what? Server, saying that I do not have IP address, I need IP address. If you studied RARP protocol, okay, or you take BootP protocol, IP address keeping as what? All zeros only, correct? Now saying that I don't have IP address, I need IP address from server. DHCP cases, right? When a host do not have a IP address, it's putting a request to a particular server, getting its own getting its IP address. Then we can use as a source IP address. We cannot assign this address to any host. In the public network, no computer system will be having this address as an IP address, please. Yes, yes. It's not only DHCP, it can be in case of BootP server also, it can case of RARP server also. So this becomes the source IP address. So now you know about all ones, correct or not? All ones means, well, like if I write it 255.255.255. Yes, what is this now? 255.255.255. All zeros we understand, this is a client has to use, okay, client has to use as a source IP address to get its own IP address. What about this one? Isn't it LBA? Is it limited broadcast address? Yes, limited broadcast, meaning whenever a particular host want to broadcast so a message to all the hosts in this particular network, it could be any network, or it can be block of IP address also. It can be block of IP address, we can use this. So can I use this IP address as a source IP address? Can we use this IP address as source IP address? Yes, those who are watching, respond. So these are the things we need to analyze while studying, like important points. Yeah. No. So this only has a destination IP. It is only as destination IP. No host in the public has nobody having this IP address. Yes. No computer will be assigned at this IP address. Is clear? Clear. Okay. So as I mentioned earlier session also, like test series plus is there. Still we have a time. Today's 26th means more than 1 month is there. This 1 month is a crucial time for attempting test series. Those who do not have any test series, try you can getting this test series plus. You can also get its 20% discount, and the advantage will be not only having the 130 plus online tests, also will be getting the booklet for this. 33 years of the booklet. What you can say, previous year gate questions. You will be getting. So followed by even like mathematics and general aptitude, then other information also will be getting with additional to this one. Okay. So now this IMS we are started the batch for online program for 26. you can also contact. Then we'll be having more than 800 plus of the what teaching hours, covering of all the aspect of the all the subjects. Okay. Then followed by theory books, exercise books, theory books related to for each subject. So physical copy will be getting. Exercise books, it is created for each subject having level 1, level 2, level 3 of 20 questions. Around more than 4,000 questions will be having. So which is, I can say, what is one of the premium product for this IMS, because the faculties almost spend years of their time to develop these books. Then as well as 34 years of the GATE previous year question bank, which I told you, having of the video solutions and alternate solution, all important things are mentioned related to this one. So another important thing to understand here is 12 personalized one-to-one mentorship sessions will be there. So that means whenever students are not able to study or not able to focus on studies, getting the various strategies to prepare the GATE exam, and so continuous motivation will be getting from the faculty throughout a year. That is the major advantage of this 12 My Plan sessions. As I told you, now we have a lot of test series, so including subject, chapter level, multi-subject, full length mock test. There are many things can be offered. Okay. So now come to the point of next question. We will see question number 2. Can you try, an organization is granted the block of IP address, okay, it need to have 4 subnets. Which of the following is not an address of this organization? Can you try? So which of the following not an address of the, so I think within 2 minutes you can able to solve it. Try it out, try it out. Yes, yes, ma. Yeah. Okay. Very good, Parthasarathi, JP and Ahmad. You have given right answer. Okay. So I think without dividing, do we need to divide this network into 4 subnet to answer this question? Do we need to perform the subnetting and this network to answer this question? Now if you observe here, this is IP address, right? So 130.34.12. So 26 bits are there. Here is the 8 octets. This is 8 bits, and this is what? 8. 3 octet I have to take full, 24 bit. Then again 64 outer at 0, 1, 0, 0, 0, 0, 0, 0. Isn't it? Because first bit weight is what? 128, 64, 32, 16, 8, 4, 2, 1. So all of you please observe the bit pattern, bit position you should know. Every bit, 8-bit number, bit position you should know, either from left to right or right to left. Position, the bit weights you should know, so that you can minimize the problem solving time now. So 24 plus 2, okay. So till this part, completely network portion only, correct or not? This is only network ID, correct? Network ID. Now it is complete, this is the host partition normally. Now it need to have a 4 subnets. To making 4 subnet, how many bits need to borrow from host ID? Number of bits need to be borrowed, because subnetting is a process of borrowing bits from host ID to what? Network side to make these subnets, correct or not? Because one network is there, further network if you want to make it means I need some more bits to configure the networks, right? To configure the 4 subnets, essentially 2 bits required. So this 2 bits also you are taking into network. This we can call subnet ID also we can call now. Subnet ID we can also call, right? Now understand, here is if I make it which is not possible as a IP address they are saying now. Suppose example, based on this 4, this can be 0001 1011, correct or not? Subnet IDs if you observe it, so 000 like 011011 possible, right? So 00 case this value is how much? 64. It can be 64 means what? 64 plus 8 possible. 64 plus 16 possible, 96 happen. The 64 plus what you can say, this value is 111. This already 64 plus 32 plus 16 I can add it, right? Isn't it? 48. The 48 plus 64, 112 it can go, correct? This is a pattern if I not add it this addresses. What are the addresses possible now? 124, is it possible? 124. So 124 as subnet, like this ID, one of the, which of the following is not an address of this organization? If you take 124 is possible, because anyway your 64 greater only have to touch it, one of them I have to take it. So when 124 possible, when all subnet 3, in a subnet 3, correct, subnet 3, 1112 plus remaining 8 plus 4 I should add it, 8 plus 4, 12th. 12th subnet ID will be there, 12th ID will be there in under 3rd subnet, 0, 1, 2, 3, correct? It is present, right? It is present now. So now 89 means 0, 0, 64 plus something, because how many hosts? 1, 2, 3, 4, nothing but 2 power 4, 16 minus 2, 14 will be there. So 64 if I start, that is 14 if I add it, 878. So 89 will be at subnet 1 I think, subnet 2, at subnet 2 this also possible, right? So 17 is before only it is possible, so that is nothing but subnet 0 only, the subnet 0 this is possible. So 130, when this 130 possible, so 01 you cannot touch, this is 1, right? Even all ones also there, so what is the value? If it is 111, okay, then this value is what? 4 ones, correct? 4 ones. This 3 ones and 4 ones, 7 ones, 7 ones highest number is what? 127 only, correct or not? So 127 only possible, last address as per this configuration. Hello, all of you tell me, as per this configuration. So now because we have purchased, how many IP addresses purchased? 26, nothing but 4 bit plus 2, 6 bits, 2 power 6, 30. 2 power 6 means what? 2 power 6 is 64 IP address are there. So last means not, we have only 17. So 12.127 possible, 132 not at all possible, correct or not? So 132 not at all possible. So as per this question, option D is answer. As per this question, option D is the right answer. Yes, all of you, is it clear? How I understand? Simple, you make the subnet or I, this cannot make, you cannot make, correct or not? In order to get 132, I need to touch this bit, correct or not? 128 position I should have, correct? So you have to observe the patterns, ma'am. In order to get 132, nothing but here this bit you have to touch, correct? This bit you have to touch, this weight 128 plus something I need to add it, correct or not? That you cannot touch it because this is network ID portion. So network ID portion, subnet ID portions are there, I cannot touch. So definitely this is not possible. Yes. So like which of the following is possible addresses also they can tell. So that can be, it can be framed as a MSQ question, right? It can be framed as an MSQ question. I hope this is clear. Now, which of the following IP address is or for private networks now. Just wanted to know this. This is very easy. If I hope you know, but you just confirm it. So which of the following IP address is or for private network? Private network. Private networks, yes. Answer it, answer it. So understand nothing but all of you from all the network IP, all the IP addresses, private network, nothing but private network can be formed by taking the IP address from class A. From class A, you understand, class A 10.0.0.0.2, 10.255.255.255. This is one network ID. Please, I am taking one network ID. Network ID only one. One network ID, if you take it, you can configure this many hosts from here to here, this many hosts. How many hosts possible? Isn't it 2 power of 24? 2 power 24 minus 2 IP addresses, can you form it or not? So this many you can form it. Am I right, all of you? One network only, this many hosts possible now. So class B. So class B, if I take class B, from class B, you know 172.16. So 0.0.2, so 172.31.255.255. Okay. You understand here class B 16. Okay. So from 16 to 31, from 16 to 31, 16 class B networks are there. In each class B network, you can configure 2 power 14 IP addresses. Am I right? So one network ID, if we pick it, so you can take it 2 power 14 network IP address, like systems IP address can be formed it. So we can use organization level communication. Suppose example, now I have in my organization, 1,000 people are there, assumption 1,000 computers are there. I do not want connect to public IP. I do not want to check the internet. Only I want to do a organization level communication, means I can use the what? One of the IP address I can use to configure or not. One of the private network ID, you can take either class A, class B, you configure all the 1,000 computers, you can communicate, right? Oh, like nobody, if nobody required to participate into public IP, you can communicate, correct or not? This, now my question to you, this private IP address, these are the private IP address, can be reusable? Are they able to reuse into different organizations, same IP addresses? Yes, highly possible. Because they are not public IP, please understand, public IP cannot be reused again. That is a unique IP address will be there. From class C network, if you see, class C network, understand class C, so 192.168. So 0.0, okay, 0.02, so 192.168.255.255, okay. So here is 256 IP address present from the class C. This is a range, you can use it. So therefore, so option A is B as well as D. Whatever this is, which address it is? 128.0.0.0. Which address is it? This one, tell me, all of you. So 128.0.0, what is this address? Is a public IP? Public IP only, correct? It is yes. So can I say this one is the first network IP, network address of a class B, correct? Yes or no? From class B network, correct? Class B start from 128 onwards only? Yes, very good, very good, very good, very good. These are the information can be captured. Very good, very good. Okay. coming into the point. Now answer. So I am giving 3 minutes of time. Try to answer this question, ma. Yes, ma. Try all of you. Try to answer this question. Yes, ma, all of you. What is the answer? Pardasarathi. Yes. So most of you given correct answer, ma. Option A is possible. Option C is possible. Option D is possible. ACD. You understand, all of you know, 8 subnets. So this given IP address is what? Which class it is, ma? The network is classful or classless? The given network is classful or classless? Answer it, all of you. Given network is classless or classful? Yes, yes. The given network is what? Classful network. Okay. And also by looking at the subnet mask, is a default subnet mask for what? Class C network, correct? So default subnet mask for class C network. Class C we understand now. So class C means host ID bits will be 8 bits will be there, right? 8 bits will be there now. We have to make 8 subnets. 8 subnets means 3 bits need to borrow. 3 bits need to be borrow. If out of 8 bit 3 bits you borrow, leftover bits for host ID part is what? How many? 5. With the 5 bit number of hosts possible in class C, 2 power of 5, 32 minus 2, 30. So therefore, you know, you see, maximum number of hosts that can be assigned in each subnet is 30. 30. It's 100% right, 100% right. That we have answered it. Now, one more thing. So 3 bits need to be borrowed. 5 bit was very good, very good. 3 bits if you borrow, so now the 3 bits becomes 1. If 3 bits are 1, what is my subnet mask? Because all are equally divided. So now all the subnet having the same subnet mask or not? All 8 subnets having only same subnet mask. Please understand. Whenever subnet sizes are same, subnet mask also same. If the subnet size subnet having the different size of the IPs, then subnet mask changes. So 3 bits are high. What 3 bits are high? So already 24 bits will be high, then 3 bits are high. What is the value? That value will be what? 200. And can you tell me what is subnet mask possible here? Subnet mask after making 8 subnet. 224, very good. 255 dot 255 dot 224, right? I hope this is clear. Okay, I hope this is clear. So what I am trying to do, we have to make this, we have to divide into 8 subnets, correct? Sorry, ma. Eight subnets. Suppose if I make it like this assumption now. Okay, 8 subnets. Let me write it as S0, subnet 1, subnet 2, subnet 3, subnet 4, subnet 5, subnet 6, subnet 7, correct or not? If numbering, if I give 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, so this is what 0, like 1, 0, 0, this one 1, 0, 1, 1, 1, 0, this is what 111, correct or not? 111. So each size going to be what? This 30 worst possible, 30 worst possible, 30 worst possible, 30 worst possible, 30 worst, 30 worst, 30 worst. Now can you tell me what the DBA address for subnet S2? Can you tell me subnet DBA address for subnet S2, 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 S1, S2, S0, S1, S2, like this, S2. Tell me all of you, tell me all of you. IP address given 200.175.56.0, right? So like I am taking the point 200.175.56.0, correct or not? So we have bits 3, 4, 5, 6, 8 bits are there, 8 bits, correct? Now how to take it? What 3 bits we have to borrow, correct or not, to make? So this is host possible. 1, 2, 3, 4, 5. So this is a host ID. Host ID has 5 bits, correct? Host ID has what? 5 bits are there. Host ID has 5 bits. Host ID has 5 bits. Now for this, network ID, if I want write network ID, what network ID? 200.175.56.0, correct or not? Now just my question to you, all of you. So write the some points, So I am asking the points, subnet number, some information I am writing. Okay, subnet number, subnet ID tell me, first host ID, can you please tell me first host ID possible, last host ID, as well as a DBA address, Can you please answer me, all of you? Subnet 1, subnet 2, subnet 3, subnet 4, 5, 6, 7, 8 are there. Okay. What is subnet ID? 200.170.56.0, correct? Can I make this, all of you? Then 200.175.56. What is this one? Tell me. First address is what? 1 only. This is what? 1, correct? This one is what? 200.175.56. What is this value? Last host ID. Tell me in this one. Subnet S1. Starting this ending one. Can you tell me now? 56. This one. 3 bits means what? What is the last one? Isn't it 31? Isn't it 31? 56 dot first one, this is what, 31, correct or 31 or 30? This is 30 only, correct or not? Total possible 30 possible 30. Yes, what is the DBA? 200 dot 175 dot 56 dot what, 31 is the DBA. Am I right? So now 200 dot 175 dot 56 dot 32. 200 dot 175 dot 56 dot 33. The first, second, like this keep on goes, right? 200 dot 175 dot 56 dot 60, 62. 200 dot 175 dot 56 dot 63. Correct? Now 200 dot 175 dot 56 dot 64. 200 dot 175 dot 56 dot 65. 200 dot 175 dot 56 dot, what is the value, ma? So 95, 200, 94, 175 dot 56 dot 95. Now my question to all of you, come to the point here. Okay, this one, see, subnet ID of third subnet could be, is it 64 only? Correct or? Third subnet ID 200.175.56.64, correct or? Isn't it all of you? Third one, right? Yes or no? Third one now. Now can you tell me, all of you, IP address? I am host, completely IP address I am asking. 10th host of the third subnet. Can you tell me? Keep on, I can write this one. I am asking, 10th host. Like IP address of, first question I am asking, IP address of 10th host, 10th host in third subnet, this type of possible, you can observe and tell me now. Meanwhile, I will write it. Fourth one is what, 200.175.56 dot, so 96, 200.175.56.97, 200.175.56 dot, what is this value? 31 I should add it now. So 96, how we got 1 plus 30, 31 we added. We have added, correct on 30. What is the value? Can you tell me this last IP address? Last host ID here. 126, isn't it? 126, 200.175.56.127. 127, correct? Now come to the point here. If I ask question, maximum now the broadcast ID of any subnet could be, direct broadcast subnet could be 200, 170, 157. Now if I ask additional question, this DBA comes of which subnet? This DBA belongs to which subnet? Subnet number, can you tell me? Subnet number of this DBA. The DBA belongs to which subnet number? Can we able to answer? Everyone, JP, Vinay, Parthasarathi, Hamad. This DBA belongs to, this DBA belongs to which subnet? Subnet number I am asking, subnet number. Subnet number 4, isn't it? Check. Subnet number 4, yes, 4 subnet. Like this you can write, right? You can write now. This all you can write, right? Yes, ma, are you able to write? Now what was this question? What is the answer of this question? IP address of 10th host in third subnet. 10th host in third subnet. 10th host in third subnet. $74. It is required to check Parthasarathi properly. So this is started third subnet. This is the first host ID, correct? First host ID, this one, right? First host ID, right? Simply can I add for this one subnet ID plus 10th host. 10 if I add, can I get answer? JP? Yes. Vinay? IP address of the 10th host. First host 65, second host, like the keep on goes or not. 10th host is what? 10th host will be what? 74? Are you sure? 200.175.56. So 64 plus 10. Yes, very good. This is 74. Always please understand, if the ask question is like related to host ID. Host ID means always go with what are the host number is given na, subnet ID plus you write the count. Subnet ID onwards you count it. If you take first ID onwards, you will get confused. Simply just subnet ID, that number you added, you will get answer now. So like this data you should observe. Given data only you should observe various questions. Now what is subnet mask? Suppose if I ask you next question, subnet mask. So mask of the 7th subnet. So since all subnets are what? Same sizes, correct or not? So 255.255.255. class A network. So they made it 8 subnet, 3 bit required, 3 bits should be high. So this 3 bits high nothing but what? 224, correct or not? 224. Subnet mask easy because sizes are same. Every subnet has same mask only single mask we are using now. I hope this is clear now. Yes, everyone. Come to the point of next question. Suppose ISP, read the question, read. Try this question now. Vinay, are you there? Try this question. Yes, everyone must try. Yes. How many people tried? JP, Vinay, Hamad. Now by reading this one, understand, okay, what is a subnet mask is? Subnet mask is what? 255.255.255.0, correct or not? 24 bits are there now. So block ID is given here 200.20.2.0. This is a block ID is given now. So number of hosts, okay, number of hosts are there. Host here 24 nothing but 6 plus 2 8. So 2 power 8, maximum 256 theoretically possible. So practically you have to remove 2. So JP saying that D is not possible. Which of the following assignment is not possible, he asking, not possible thing he asking now. Vinay, what is your answer? So this is a basic information, we captured it. If I take option A, let's try it whether able to create or not. Option A. You might have studied like variable length subnet masking, correct? Variable length subnetting mask, correct? Have you studied this one? VLSM in part of classful as well as a classless also. Part of classful as well as classless also. I hope this is clear. Variable length, as per the requirement, block have to create it. Okay. Let's try option A. So total possible 256 hosts are there. Now understand, some of these options should not increase more than 256. So this value is 150, 170, 195, correct. This is 18, 229 less than only. So this also 120, 120, 160. 180, fine, less than, this also less than, every option is less than of 256 is there, first thing, okay, we should know. Come to the point, now the division can be happened like this. Option A if you see, okay, I want to make it subnets, correct or not? Total block size is what? 256 only available, right? 256 available sizes, right? 100, 50, 20 I have to allocate it, right? So I am making first 100, 2 parts I will make it. This entire address space I will make it 2 parts. All are under 256, very good. So I made it 2 parts. Listen carefully, ma'am. Some people made a mistake, just observe it clearly, very important thing this one. So I made it 2 parts, right? I made it 2 parts, right? To make it 2 parts, how many bits I need to borrow? To make it 2 subnets, how many bits I need to borrow? 1 bit is enough. So now 25 means 1 bit I have to borrow, right? Leftover bit 9 bits are there, 7 bits are there, 7 means 128, 128. This size is going to be 128 size, this is going to be 128 size, this is 128. So therefore option 100 I can assign, 128 nothing but I can assign 100 hosts I can assign, this is subnet S1 assumption now. Then next required 50, 20 to 25 required. So to assign this 20, what I will do again this shape, this part. So what I am doing now, this is they started with the number 0, this is 1. So if I write it some IP address, let's take this, what given IP address is coming 200.20. given, right. So I am making now 200.20.2.0 is there now 00004, 8 zeros are possible, right. First bit I will take it, this first bit is 0, 200.20.2.0 reserved. So this will be there now. This part is 200.20.2. This bit can be 1. So 1 is reserved 0000000 like this. Understand now. Bit is 0 or 1 now. But further I need 50 assignment. So now what I will do it, I will make further this part half I will divide it. Half I will divide it. Understand now. So meaning this 2 bits I am reserving. This can start with 200.20.2.10000. So 000 like this now. This size is theoretically 64 theoretically. Now 50 I can assign easily. Yes or no, 50 I can assign it. Then 20, 25. Okay. Now this size is what, 60. This size is what, 60. What I will do? 3 bits I will borrow it. Further I will do this division now. Further I will do division. Therefore this will start from, so this will start from 200.20.2.10, this one. So now see 0, this is what you can say 1, this part is 10, this becomes 1 like this. So 10, 3 bits I will be 1, okay, 1. So this 3 bits are reserved 0000 like this, understand now. So here size will be 64 means 32, right. Theoretically 32 size will be there, 32. Now I need it what? I need what? 20, 25, correct or not? So I can make it 25 assign. Can I assign 25 and 20 assign? Yes. So option A possible. Option is possible. However, is it clear all of you? This configuration is clear? Or else you can do this area for first network, this area you can do subnetting. This is what variable subnetting you can tell now. I can accommodate. So now for each subnet can I able to write? Can you tell me in this moment what is subnet mask for a subnet mask for last subnet? Subnet 1, 2, 3, 4. Fourth subnet, can you tell me subnet mask for fourth? Yes, some of you tell me. What is the subnet mask for this one? Because this sign is same. Now we are asking subnet mask. Tell me subnet mask. So 255.255. Yes. What is subnet mask for this? Tell me those who are watching. Yes, Vinay, JP, Pardasarathi, Hamad. Very good. 3 bits are borrowed means 224. Very good. Like this. So everything you can write. Subnet IDs you can write it. Subnet mask. No, Pardasarathi, that is mistake. Not last octet cannot be 255. It should be 224. Why? Because so 3 bits are you are fixing, correct or not? Here also 3 bits you fix. Here 2 bits you fix. Here is 2 bit fixed. For this subnet mask, if I ask you what is subnet mask, 200.20.2.128, is it? For this subnet mask 200.20.2. 2 bits reserved means what? So 128 plus 192. Am I right, all of you? Like this you can write it. Yes or no? These are the observations now. So these are the observations. Therefore I can say, so which of the following assignment is not possible? This is possible. Option B possible. Can you verify? Similarly, option B possible. Does option B possible? I am asking everyone. Option B. Option B possible. Verify all of you. First I will do off. 60, 60, 60 required. Okay. So this also off I will do it. This part variable length I can make it like this. Okay. Now what I will do it here, 60, 60, 60 I can assign, right? What I will do, I will assign this 60 I can assign, 60 I can assign, 60 I can assign it. The sequence 25, 10, 14 required, 25 required. So I will do further this one. This size is what, 30, this size is 30, okay, this size is 30 will happen now. So therefore I can assign what, 25 I can assign. So suppose if I assign 25 here, 25 I am assigning here. Now here further I will do the division now. Here is theoretically 15, 15 is possible. Now 14 and 10 I can assign it, 14 and 10 I can assign it, 14 and 10 I can assign it, yes, 10 and 14 else, this is also possible. Sir, A, B, D possible, C is not possible, got my mistake. Very good, very good, very good. B is possible. So please understand, this is a right answer for this question, because there are many things to be done. Further division, not this able to do it. This also can able to do, this also can able to do, this also can able to do. So answer is what? C. Everyone is clear, or should I solve this one? Option C. Same way you have to apply the division. For B, C also we can, C, D also can try it. Yes? Chalo, we will move on to the next question. Can you answer this question? It is also interesting question. Try this question, all of you try this question. Do not leave the session, ma. Very important things we are going to be discussing next also. Yes, what is the answer? Yes, Ahmad. Pardasarathi. Not required 3 minutes to solve. I mean, less than 3 minutes you can able to solve it. ISP has the following CIDR based IP address available with it. Now, by looking this one, can you tell me what the block size they purchased here? block of IP addresses, 12 bits are nothing but 2 power of 12. 4096 IP address we have, 4096 IP addresses are there. They started configuration. They started. ISP wants to give half of this IP address to organization A and a quarter to the organization B. If the first IP address will be assigned to a network which consumes more number of IP address, first IP address. Can you tell me first IP address? Without solving this question, I am asking, what is the first IP address? First IP address chosen from this block. Can you tell me what is first IP address? All of you. IP, first IP. I am not asking first host IP. First IP. Isn't it 200.128.0 itself? This itself first IP address. Correct? Correct or not? This is given to a subnet as more number of IP address. So let me do the division. Okay. Total block size is 2 power of 12, nothing but 4096 IP address are there, off. So done the division like this, off. What is the off value? This off value is what? 2048. So this off is 2048. So this off is given to what? Organization A. Now second off again, quarter means what? You have to divide further. So 1024, correct or not? So this part can be given to B or this part can be given to B. Let's say this is given for organization B assumption now. So this is kept with what? So kept with ISP only. Okay, kept with ISP. Now see. This is a overall configuration, correct or not? Overall configuration now. So first IP address, so here is how many IP address? 2048. So they said first IP address given to which organization which has more. Sir, either first or second quarter given to be. Very good JP, very good observation JP. So this is first IP address given here now. Okay, first IP address given now. So just a minute. So now here we can do the configuration like this. So first half you divided, correct? Half you did. This entire block has 4096 block has. We purchased cake of one piece of cake having 4096 IP address are there. Half divided. This portion has 2048, right? Half means for 2048. Okay. So this is given for what? Organization A. Now this IP address has, you understand, 200 dot, okay, 200 dot, let me take given one, where is given? 200.200.128, right? 200.128.0, this is given here now. Okay, how many network ID portions are there? Network ID portion 20 bits are there. So now if you start observing 200.200.8816, then 4 bit you have to take it 100000000 like this, correct or not? So this is the network portion, correct or not? Now here is, so this again 000000000 like this. This entire post is what? Host ID portion, host ID, correct or not? So we have to make a subnet. So this bit is 0, this is resolved. This 0 portion given to this one now. Now this portion started with what? What is this portion now? 200 dot, please understand, 1000 we cannot touch, okay. Now this bit is what? 1, this bit is 1 now. But we have to quarter means what? Further I have to divide it. I have to divide this further, right? Further I have to divide it. So to divide this one, one more bit you have to borrow it. So the bit is what? 1 0, one thing like this. 00.0000000 like this we have now. Other possibilities, this is 200.100.1000, 4 bit. The bit is what? This bit is what? 11, correct? 11. So remaining 00.0000000, this first part only, correct or not? So till this what subnet IDs only, correct or not? Either I can give organization, this area can be B or this can be B, one of them can be given now. Now what is the question you ask? Now we can answer this question from this data only. Then what is the possible value of third octet of organization B? Third octet, when you write this IP address here, so this part if you write it 200 dot, this value is how much more? 128 plus 1248, 128 plus 8, 136, correct or not? So 136 dot 0 onwards it will start, correct or not? This will start 200 dot, so 136 plus 4, 140 dot 0 like this. 140 onwards, 136 onwards will be there, correct? What is this last IP address? Can you tell me? 200 dot. So this 128 plus this can be full, right? I mean, where is this one? We cannot touch this also, right? This 10 reserved only, right? 10 reserved only. This bit 2. 128. This value is 10 reserved. So 136 plus 2, 138 dot 255, correct? 138 dot 255, this is possible. So 142 to this one 200 dot 140, this is completely 140, this can change, right? This can change what? 3. So 143 dot 255 can happen. Check it, 138 only, is it? This will be 3, right? 3 means so 9, this will be go 9, 139, yes. So now come to the point. So which are the third octet will be? 135 cannot be, 141 also cannard be, 141 possible, check here, 141 possible, 128 plus these two bits are 1. This value is how much? It can be 15, 155. Third octet, is it possible 141? So 136 which we got, 140 we got. Can you check 141 possible? All of you? Sir, yes, 141 within quarter, so it is possible. Sir, 141, 136, 140 are answer. Yes, check, all of you check, So now there's simply what is the possible values of third octet of organization B. Organization B when we are in this form, so IS 136 to 139 only possible. This is reserved, the bit is can be 11, it is reserved. This value itself 140, so 143 can go, 143 possible, right? Yes, possible. If they ask for network ID of third octet means that is possible. Third octet they are asking, correct on. Third octet means what? Any third octet can possible, right? Any third octet possible. Yes, you are right. Yes, one, because we are not restricting to the point network ID, correct or not? So what is the possible values of the third octet of organization B? In entire organization B, whatever, if I take this organization B, this all third octets possible. We have to check it. So this also possible, right? This also possible. 141 also there. Yes, 141 also there. You have to be carefully how to answer the questions. I hope this is clear. Everyone, is it clear? Okay, we'll move on to, because see, understand overall conclusion. These are the things need to be focused. So now, means classful you should know about these informations. All class A, B, C, their ranges. Role of this 127 we called a loop back address also. You need to focus, understand now. Subnet over 32-bit number and preparation of the subnet mask by giving the different networks. Subnetting classful system with the various models are there, which One is fixed pattern as well as variable patterns that you would observe. CIDR notations and the rules to form a CIDR representation, subnetting in CIDR also, and supernetting CIDR as well as class 4. These are the information thing. These are the things need to be revised well from this chapter, from this topic you can see. Clear? Next. From next topic, flow control. In flow control, you should aware of transmission delay, propagation delay, queuing delay, processing delay. So transmission delay nothing but L by B, correct? Propagation delay is nothing but distance by velocity, right? The queuing delay and processing delay depends on the router speed only. Now, you should aware of sliding window protocol. Under sliding window protocol, stop and wait ARQ, go back and SR protocol. You should know efficiency calculation for all things, throughput calculation, sender window size, receiver window size, sequence number calculation. These are the things need to be observed from chapter number 2. Am I right, all of you? Yes. So we should have more clarity over this all. We should have more clarity over this one. Okay. Can you tell me what is the efficiency of stop and wait protocol? Some of you tell me what is the efficiency of the stop and wait protocol. So efficiency of GBN protocol. Third one. So let me write it here better. I will write it. I am asking you point efficiency of stop and wait protocol. Efficiency of stop and wait protocol. Efficiency of GBN protocol. GBN. Third one is efficiency of SR protocol. Can you please answer? Efficiency, useful time by total time, right? Useful time what? Simply transmission delay by total time. What is total time? Transmission delay, propagation delay will be there, correct? Then queuing delay, processing delay, yes or no? Plus, plus again transmission delay of ACK, then propagation delay of that ACK packet, correct? This only total time, all of you? This is efficiency, right? So my question to all of you, this is a propagation delay of a main packet, propagation delay of what? ACK packet. So ACK packet is very small size. ACK packet is small size, right? And the main data packet is a large size will be there generally, So this relation we know, transmission delay of data is greater than of what? Transmission delay of only pure ACK. This relation holds good or not? This relation, only ACK packet. So taking at bandwidth is same, transmission delay of data is greater than of transmission delay of ACK. Is it true? Everyone, JP and other people, try to respond. Respond. Yes. Now my question to you, propagation delay of data and propagation to ACK same or different? Propagation delay of data packet and propagation delay of ACK packet, are they same or different? Required response. Very important observation this one. Because sometimes we do silly mistake while calculation if we do not have a clarity over this. Very good. Always same. It is only purely depends on the distance, velocity, signal speed, no relation to the packet. No relation to the packet sizes, please understand. That's the reason we have to consider it. Okay. So what about this one? For shortening this one, many terms can be ignored. If they are not given, you can ignore, like example, this you can ignore, this you can ignore, or this also can be ignored here. Therefore, transmission delay by transmission delay plus 2 times of propagation delay also we can write it. Yes or no? Now, can you tell me with this respect, GBN in go back N, we are sending N packets we are sending. So, transmission delay of N packet by what? Can I take it transmission delay plus 2 times of propagation delay by ignoring the few things approximated? Am I right? Here SR protocol, sender window size we are sending. Sender window size, transmission delay by transmission delay into plus 2 times of propagation delay into 100%. Into 100%. Correct? I hope this is clear. I hope this is clear. Similarly, fourth point if I want to observe, throughput. How to calculate throughput of anything? Throughput. Throughput. So again please understand, simply data size, how much data you sent out of total time only, out of total time. Data size by total time, or else throughput also we can say, effective utilization of the bandwidth also we can say. Effective bandwidth also we can say now. So this is nothing but utilization of the bandwidth, efficiency into bandwidth also can write it. Effective utilization of the bandwidth, efficiency into bandwidth we can write it. That you have to understand meaning. Effective utilization, what is the rate is there out of how much I utilized, how much I utilize. So what is the rate of transmission out of how much I utilize, that is what efficiency into bandwidth also can write it. So simply whatever data you send out of total time only, data by total time. That is what throughput we know. In terms of memory, CO time also we discussed, right? Throughput of a memory system, number of bytes or words transferred per unit of time, correct one, that is throughput. Or number of instructions executed per second, that is what instruction pipeline throughput also we have seen, right? Here also same thing. Amount of data transmitted per unit of time is total time here, because you have to consider this all the things here now. So this we know, correct? Now coming into the point, suppose in case of SR and GBN protocol, how to find sender window size, how to find sender window size. So what you can do it, you should know the bandwidth. Suppose some bandwidth is there, through bandwidth find out the round trip time, correct or not? So bandwidth rate, so by using this bandwidth and round trip time, find the sender window size in terms of bits, How to calculate, bandwidth per second this much data you are able to send. If I use fully utilization of the round trip time, how much data you will send? So that you will get a window size. This window size by packet size, if you define, you will get in the window size of in terms of packets you will get, Then if you know the number of packets in the window, I can find out what sequence numbers required, sequence number bits required, particularly sliding window protocol, particularly GBN, SR protocol, easily we can able to find out. Let's observe. So one question is there like this, can you answer now? Try to answer this question. Few other things can be we will observe later. Just I am giving 2 minutes time. Try this question. All of you must try. Yes, what are answers now? Sir, only maximum window size given as a sender window, receiver window. Option D you are telling. Suppose sequence number bits required in a sliding window protocol is 4 bits are there. Which of the following statement is are true? One thing you understand, sliding window protocol always talks about sender window size only. Sliding window protocol, it will not look into receiver window capacity. In case of GBN, we will see. In case of GBN, receiver window size what? 1. In case of SR protocol, both are having same size, that we know. Okay. The maximum window size is 8 if select to repeat protocol used. Sliding window protocol is 8, 4 bits are there. With this 4 bit available sequence number possible, how many? 2 power 4, 16 is possible, right? 16 possible. So maximum window size 8 if select to repeat protocol used. Statement A is true or false? All of you. Option A is true or not? Hello, all of you? Yes or no? Off we can use. Maximum window size could be 16 for sliding window protocol. Maximum window size could be 16 for sliding window protocol. Sliding window protocol. Maximum window size 14. Why 14? 4 bit available sequence number, 4 bits are there. 4 bit nothing but 16 numbers possible. Sliding window, maximum window size could be sliding window protocol. We are asking for sliding window protocol. Sliding window protocol is a concept, correct or not? Okay, doubt is there now. Maximum window size could be 16 if GBN protocol used. Is it true? Maximum window size could be 16 if GBN protocol used. Option C is true or false? Option C. Option C is correct or false? Respond. Hello everyone, JP? This is false. The maximum window size could be 15. Maximum window size could be 15 if GBN protocol used. Option D is true or false? Option D is true or false? What about other people? So available sequence, no, sequence number bits required in sliding window protocol. Available sequence number is what? 16 are there, which are numbered to here. Now in case of GBN, in case of GBN, what we do? So GBN cases, here is a sender window will be 15, so receiver window equal to 1. So this is possible, true. Now think for this option B, maximum window size could be 16 for sliding window protocol. D is true, C is wrong. Maximum window size is 8 if selective repeat protocol used. 8 0 to 7 and receiver for also 0 to 7. Now what about this one, B? Think B, option B, think on option B. Is it true or false? All of you. JP, Hamad, Pardasarathi, Vinay. maximum window size maximum 14 possible. If this 14 possible, then how this 15 is possible then? You telling maximum window size 14, maximum window size 15, how it is possible in case of GBN? If it is growing, 14 is the maximum, 15 is not possible, right? So 15 is plus sender. No. Total how many sequence number we have, tell me? Total sequence numbers how many are there? SJP and Parthasarathi, all of you tell me, think properly, think. So false, because we utilize one less frame. Where is one less frame? Sliding window protocol, sir, 2 power 4, 16, very good. 16 sequence numbers are available now. So 0 to 15, total 0 to 15 sequence number I can use for sending this the one, correct or not? In a sliding window protocol concept, if you see window wise you have to send, correct or not? Window you have to send slide wise, correct? Pipeline concept wise you have to send it, correct or not? Am I right or not? Window you have to send it. Sir, here maximum window size means either sender window or receiver window or both. But in a sliding window protocol, we won't specify on what you can say receiver window size will specify. So when it comes to exact implementation, when GBN we specify it receiver window size 1, we should use 1 only. In case of SR protocol, we specify the receiver window size is same as what? Sender window size. And a sliding window concept, simply window size we have to send it, correct or not? Can't I use all 16 sequence numbers? Yes, definitely duplicate will create it when the suppose ACK is lost. So duplicate packet, that's to solve that problem only we adjusted window sizes, correct or not? Why is GBN protocol, why we are using sender is 15, 1 is for receiver. In case of SR protocol, why we are 50% using? We are facing the duplicate packet issues, correct or not? Same packet deliver but receiver not able to identify. Am I right or not? See, one example I will tell you. One example I am telling. So just a minute. Okay. Suppose simply I am taking available sequence numbers. Let's take 4 are there assumption now. So 0, 1, 2, 3, 4 packets we have sent it, correct? 4 packet we sent. So receive done. Now ACK sent assumption now. All ACK lost. He is received the packet, all ACK lost. Now it is sending same one 0, 1, 2, 3, correct or not? You will wait till timeout time. Then you will retransmit now. So he received 0, 1, 2, 3, received already. Now again came 0, 1, 2, 3 came, correct or not? 0, 1, 2, 3, 0, 1, sorry, packet we received 0, 1, 2, 3 we received, correct or not? Am I right or not, all of you now? Now how he able to identify whether you have to discard or not? He may be expecting like 0, 1, 2, 3 only expecting, it came, correct or not? How to resolve this problem? Can you answer me, all of you? He received, he sent acknowledgement, acknowledgement lost. So we have where that came into picture is available sequence number -1. Why like this? Why like this? Now my question to just simply answer it, how to resolve this problem? Hamad, JP, Parthasarathi, how we can resolve this problem? Now he is use this all sequence number. 4 as a 4 used, he also using, he is also using, correct or not? 1 by only receiving, because by default receiving 1 capacity, like 1 done. Now expecting 0 1 2 3 will expect. So 0 1 2 3 came. Now he has to discard this one and send acknowledgement. Sir, we use half of them instead of all of them. That is SR protocol. SR protocol is what? So either you increase this, if suppose if you make a window size 4, you to available sequence number you can increase 8, or if you either you are keeping available sequence 4, you reduce to 2 window. That is SR protocol, correct or not? GBN says, what is GBN says? Now for sender co, use it 3 and receiver is what? 1. A receiver window you have to make it 1. Therefore you are going to use 0 1 2 only. So 0 1 2 only. So 0 1 2 nothing but he expect for 3. So you will send what? 0 1 2. It will not match, we can detect it. Sir, increase the sequence number or reduce the window size, window sender size, correct? That's what. GBN case we reduce this one or increase this one, correct or not? So now sliding window uses all numbers or not? Can sliding window protocol use all sequence numbers? When it comes to implementation of practice GBN SR, we are adjusted the window. Am I right, all of you? We adjust the window. Yes, respond. To resolve this duplicate problem, we adjusted sender window size or we adjusted. Otherwise, sliding window protocol can use all available sequence numbers or not? Yes, available sequence number can I use or not? Yes. So therefore, what is happened now? It can grow up to 16 we can send it. 16 you can send it. But in GBN SR protocol, you cannot send it. You cannot use 16 as for sender or receiver. I hope it is clear. JP, Hamad, Parthasarat, is it clear? Come to the point, come to the next question. Now try to answer this one now. Consider network two systems location 200 kilometers apart. Bandwidth of the network is 4 megabits per second. The propagation speed of the media is what? 8 microsecond per kilometer. Select repeat is used on this network to send a data with a frame size 3200 bits. Assume that processing delay at nodes are neglected, then the minimum size of bits of the sequence number field has to be in SR protocol, because they use SR protocol only. Minimum number of sequence bits required to transmit this one. Answer it, all of you. Try to answer this question. Yes, try, all of you try. Yes. How many bits required for the sequence number field? Yes, JP, what is sender window size you got? How many packets in terms of packets, number of packets sender window or sequence numbers for sender? Very good, 7 is right answer. 7 is right answer. How many people got 7? Sender window, can you tell me? Sender window nothing but receiver window also will come. Then I can get the total available sequence number. So sender window you got 41. You also got 41. Together is 82. 82 represent we need what? 7 bits. Too good, too good, too good. How you done? What is the process you did? What you did first? Yes, tell me, tell me. Other people, did you get the answer? Other people. Sender, first of all, get the sender window. Sender maximally packed. So can I use this concept one thing like bandwidth delay product. Bandwidth delay product is a maximally pack of network which I am transmitting. Maximum packet transmit, maximum data transfer, that window in terms of bits I can get it. Yes, yes, 100% efficiently I should take it. True, that is true. 100% efficiency nothing, fully I am sending, fully time utilized, full round trip time utilized, fully round trip time, that is only you have to use it. There is no other way because I don't know about the sender correct or not. They did not mention how many packets are there. I should go with what? Efficiency is 100%, fully packed network I should consider, fully packed network consider it. Now see what is the bandwidth is given now? 4 megabits per second given, 4 megabits per second is given now. So propagation delay is what? Distance by velocity I can take it, distance by velocity. So distance by velocity, what is the distance? I think not required. Propagation speed is minus 8 microseconds per kilometer given. So I think I can get it like 8 microseconds per kilometer. There is 2000 kilometers, right? 2000 kilometers, right? This is 1600 microseconds I will get. 16,000 microseconds I am getting, correct? Propagation delay. Now can I get it network capacity? Simply channel capacity, maximum utilization channel capacity. So the channel capacity is nothing but what you can say, propagation delay into bandwidth, right? So 2 times of propagation delay into bandwidth I can take it. So 2 times of this 16,000, so microseconds into 4 into 10 power of 6, so bits per second, right? So this value 2 into 16,000 into 2 power of this we can write it. So 10 power of minus 6 seconds we can write it, right? Seconds we can write it into 4 into 10 power of 6 bits per second. Second get cancel. So this term cancel. Now we got this value, right? 8, 2 power 3, 2 power 4, 7. So 128,000 bits we got. This is the my window size. Can I say this only window size? This only window size, correct? In terms of bits. What is the packet size given? The frame size is 3200 bits are there. 3200 bits. So now I can write it number of packets. So number of packets equal to 12. So this 128,000 bits divided by 3200 bits. This value is how much it is getting, ma? Is it 40 only? Forty only? All of you, is it answer is 40? 40 only? Hello? Kindly respond. So therefore sender window size. So sender window size we got 40, correct or not? Sender window size 40, this implies what? So receiver window size also 40, correct or not? So now available sequence number should be what? 80. To address this one, number of bits required for sequence numbers equal to what? 7 bits required. You might have used the formula, correct? JP, efficiency formula, n into transmission delay by total time, correct? Through which one you got another answer? Jaiprakash. What about other people? Parthasarathi, is it clear? So please understand how I get, sir, this part, capacity of the link, because efficiency 100% at my what is the pipe is full only na. Channel capacity, pipe capacity we have learned. Fully packed, correct or not? So fully packed means otherwise, other way also we can calculate. Other way also can calculate. What is the other way I can do it, 1 second 4 megabits per second you are able to send it. In one round trip time, how much data you will send? Round trip time, 2 times of propagation delay, correct or not? 2 times of propagation delay. So propagation delay given 2 times of 32,000 microseconds. 1 second 4 megabits you send it. Now 32,000 microseconds, how much data you will send? That is only the same thing. That is also way. Or else you can use this efficiency expression also, through which also you can solve. Ultimately you have to solve the question, but it is not compulsory to use which formula. Try to understand the meaning only. Try to understand the meaning. So come to the point this. Try this question, try. Assume utilization of channel is 10% when stop and wait protocol is used. The network bandwidth is 10 megabits per second. Sequence number bits use 3 bits. If we wish to implement the sliding window protocol, MSQ question it is, which of the following options are true? Throughput of the channel is 1 Mbps when stop and wait protocol is used. Maximum throughput of channel is 7 megabits per second if GBN protocol is used. Maximum throughput of channel becomes 4 megabits if I select repeat protocol is used. Maximum sender window size is 8 if selective repeat protocol is used. Yes, what are the statements are right? Answer it, answer it. Yes, quickly answer. Option A only answer. Others are not possible. As we know, throughput of any channel. So throughput of any channel is what? Efficiency into bandwidth. One option we have, other options also there now. So throughput of the stop and wait protocol, efficiency given 10%. Into bandwidth is what? 10 megabits per second. Okay. So 0, this value is what? So can I say 1 megabits per second for stop and wait protocol. So throughput of a channel is 1 megabits when stop and protocol used. So option A is true. A is true. What about B? Maximum throughput of a channel 7 megabits per second if possible if GPN protocol used. Now sequence number bits are how many are there? In case of stop and wait protocol, how many sequence number you have? You are able to send only one packet, correct? We are able to send what? Only one packet at a time, correct or not? Now in case of available sequence number, I am calculating here. Available sequence number will be 2 power of 3. 8 sequence numbers are there now. First case GBN if I use. So GBN, what is sender window size? Is it 7 or not? 7 or not, all of you? 7. Now tell me what is the efficiency possible now? Efficiency of a sender. Now, so if you are sending, so please for n equal to 7 you are sending nothing, efficiency 100% only, correct or not? When you are sending your full capacity, now efficiency is what? 100%? Hello, tell me all of you. Full capacity sender. Sending means what? You are sending what? 7 you are sending, correct or not? 100% you are sending, isn't it? Yes, right. Then therefore what is throughput possible in this case now? Throughput possible in this case now. So now 100% efficiency into what? Bandwidth, correct or not? What is the bandwidth is possible now? Okay, if I send it, what is, sorry, my point was here. The network bandwidth 10 megabits per second. 10 megabits per second network capacity is there. Sequence numbers used in 3 bits. If you wish to implement sliding window protocol, yes, that is utilization 10% is there. So total 8 possible here. Okay, just think here. Now what is the throughput can be generated now here? SJP, how you got that 7 megabits per second? How we got? Yes. What about Pardasarathi Hamad? Is it 7 Mbps is correct? Seven Mbps is correct. Very good observation. That is transmission delay by transmission delay 2 times of propagation delay. We are sending 1, but now we are sending 7. Correct or not? Is it? We are able to send now 7. So now 70% utilization is there, right? So I should not make it this 100% now. It is utilizing what now? 70% of it. Correct or not? It is now utilizing what? 70% of it. The 70% of this bandwidth is what? Now 7 megabits per second. 7 megabits per second. Very good observation. Yes. So this also correct now. What about this maximum throughput of a channel 4 megabits per second if selective repeat protocol used? Selective repeat protocol use sender window size going to be 4 only, correct or not? Sender window size is going to be 4. Yes, yes. Now sender window size is 4, nothing but what? Efficiency is going to be what? How much you are utilizing now? 40% only, correct or not? 1 packet 10%, 7 packet 70%, 4 packet 4%. Clear? This is only rule for me. Utilization channel 10% when stop and protocol used. We are sending one packet, right? You are able to send 1 packet. So 1 packet is what? 10%, 7 packet 70%. Now 4 packet 40% now. When 40% is the throughput is possible or 4 Mbps. This also write it. Maximum sender window size 8 if selective repeat protocol. This is not at all possible now. Therefore ABC is right answer. ABC is right answer. This can be 4 questions, please. 4 questions, please understand now. But all compiled, all are compiled because you can see these are different questions. But just I kept into same options so that we can observe as a MSQ question. So move on to next question. Move on to next question now. Answer this question. Suppose a signal speed is given and the distance between the two connecting nodes also given, distance given. The support bandwidth of in this network is what? 10 megabits with a frame size is 100,000 bytes. If the network using GBN protocol with no packet loss, find the maximum window size if channel is used to full capacity. Full capacity means efficiency. Yes or no? This is full capacity, nothing but efficiency 100% or not? Answer it. Answer it. Maximum window size, sender window size only we need, right? Sender window size only we need, right? Sender window size. Yes, yes, what is the answer? So efficiency of GBN protocol is what? N into transmission delay by transmission delay 2 times of propagation delay. So JP, what is one indication? One? Or else we can also use like this also, correct? Find the capacity of a channel. So 2 times of propagation delay into what? Bandwidth. Propagation delay, find out, bandwidth you find out. So this will come, so window size in what? Bits. So this you divided by what? Packet size. So packet size. Should divide by packet size, correct? Or packet size. This also gives answer. N equal to 1 you are getting. Transmission delay. Did you check these properly units? Here is bytes are there. here meter per second is there, and the given is what, kilometers are there, connecting 100 kilometers are there. Transmission delay you got 80, propagation delay you got 1. No, verify. What about Pardasarathi? Propagation delay is distance by velocity. The distance given 100 kilometers. 100 kilometers. Velocity is given 2 into 10 power of 8 meter per second. Meter per second is there. 100 kilometers by, we can write 2 into 10 power of 5 kilometer per second, we can write it. Kilometer get cancelled. This is 50 into 10 power of minus 5 seconds comes. Then we need 3. Should I left shift 0.50 into 10 power of minus 3 seconds? So 0.5 milliseconds. Propagation delay is what? Propagation delay 0.5 milliseconds. Very good. Now, so what is the capacities? So capacity of a channel equal to 2 times of 0.5 into 10 power of minus 3 seconds into, what is the bandwidth is given? Bandwidth is 100 megabits per second is given, right? 100 into 10 power of 6 bits per second. Second get cancelled. So 3 times get cancelled. This is 2 into 0.5 into 100 into 10 power of 3 bits. This is the window size we got in terms of bits by what is the packet frame size? 1000 bytes. 1000 into 8 bits. 8 bits. 1000 into 8 bits only? Yes. Okay. Then this cancel. Okay. Then what is the other things can be cancelled here? So 0.5. Here is 50, 100 by 8. Am I right, all of you? So 1 point get cancelled. 5 to the 10, 100 by 8. 100 by 8. So what is this only correct answer? Or anything is missed here? Ten power 8, 10 power 6, transmission delay. When it is comes to window size, not going to be, sir, window size 12.5, yes, correct, 12.5, 12.5, correct. This is correct only, yes, this only. Then 12.5 nothing but 13 only I should answer it, correct? 13 is answer now. Find the maximum window size if channel is used full capacity, if a network use GBN on protocol only, find the maximum window size, So window size always refers to sender window size only. 13 is the answer. Yes, I should make it 13. But 13.5 you got. 13. Somebody got 13.5. JP, how much you got? 12.5 only. Previously also told. 13.5. 13.5. Somewhere mistake is there. Any mistake? We have done propagation delay, full capacity this part only. is it effect of transmission delay? How much we got? 80 into 10 power. Sir, but sir, 13.5 by using the efficiency formula. Sir, if we add a transmission delay, 2 times the propagation will be getting higher value. Okay. The transmission delay is added, right? Okay. Therefore, they should, in this case, this is also right. The way solving this is 100% right. Now, in this case, if you ask find the maximum window size, channel used its full capacity means what? 100% efficiency only. You write maximum, whatever possibility is there, I should go with 13.5 means I should answer it what? 14 only I should make it. Because it should be maximum, this more than 14 is not going to be cross, correct or not? Definitely they will mention the range. This cases is they will give a range here. So they can given a range to 13 to 14 can be given. But suppose actually the gate if they ask like this, but such possibilities comes, then what they can do, instead of asking window size, they will ask number of sequence bits required to for sender window or GBN. Can you tell me now? Number of sequence number bits required for GBN as per this question now. 13 also right, 13 to 14 we can tell, because this is also right. When I told full capacity, I am taking into my what you can say capacity of a channel only, 2 times of propagational bandwidth, this is 100% right. Yes, that is also right. Now my question to what I can do it in this moment, instead of asking sender window, so we can ask number of bits required to for a GBN sequence number field. So now 14 plus 1 15 or 13 plus 1 14, same way only na, 4 bits sufficient. If it is 13 or it is 14, it should be what 4 bits are sufficient or not? Correct all of you? 4 bits are sufficient to answer. So meaning sequence number field, yes sir, that is sufficient, that is right, 100% right. Next question now. If frame size 1500 bytes are sent over 1 megabits per second, channel from host A to host B separated by distance 10 kilometers, the signal speed is given here. Header size negligible, 3-bit sequence number is used. What is the maximum channel utilization, the protocol used in this above communication GBN? Efficiency they are asking now directly. Efficiency of GBN, calculate. N into transmission delay by, so transmission delay 2 times of propagation delay. Tell me answer. Straightforward question. Yes ma, what is the answer? So what is n value? Sender window size is 3 bits are there means what? So 8 numbers possible, 7 only you should use. 7 into transmission delay by what? So transmission delay 2 times of propagation delay, correct? should I just a minute. Available sequence number bit is, because may not come 100%, am I right? Why? Because you know, you have to see this configuration, right? Sometime network capacity is more, I restricted my window size, correct or not? Hamad, we cannot tell this 100%, because depends on the transmission and propagation, like total round trip time. Out of round trip time I used 7 packets, suppose, but that network capacity may be more, correct or not? That based on that only my efficiency will come, right? $99.7 you got. What about other people? If it is 100% efficiency, how many packets you are able to send it? Can you tell? If it is 100% efficiency, suppose if I take it, how many packets? That sender window size is equal to this 1 plus 2a only, correct or not? So 1 plus 2a. So 1 plus 2a means what? Transmission propagation delay. Transmission by transmission delay by propagation delay by transmission delay, correct or not? Right, number of packets. So transmission delay you got 0.015 seconds, propagation delay 5 seconds you got. So this 1 plus 2 times of propagation delay by transmission delay, correct? 1 plus 2 into propagation delay, how much you got? 5 seconds. 5 by, so transmission delay 0.015. So 0.0015 seconds. This value 1 by 10 by, how much this will come? Can you tell me now? Exactly this, can you calculate? One plus 2a, propagation delay by transmission delay. Some of you calculate and tell me this value, particular this value. Are you sure? Transmission delay? Transmission 1500 bytes by this one. Transmission delay is equal to 1500 by 1 into just a minute. Is it clear now? Is still buffering? Okay, okay, okay. You tell me this values, transmission delay and propagation delay. JP and Pardasarathi. Transmission delay and propagation delay. So 1.5 milliseconds we got and propagation delay. Amar, this values please some printing mistake, 2 into 10 power 8 meter per second only, or it is if I take it 3, what is the 10 kilometers, 10 in 10 power of 3. Okay, let keep it 3 only, no problem. I will keep it 10 kilometers means 10 power of 3 meters I can write it. So 2 into 10 power of 3 meter per second. So this cancelled. This we got, so this is 5 seconds. 5 seconds. The 5 seconds is nothing but 5000 milliseconds only. 5000 milliseconds we got. So as per this capacity, if you see, 1 plus 2 times of A, 1 plus 2 into propagation delay, 5000 milliseconds divided by, so 1.5 milliseconds, correct or not? This value will be almost 10,000 by 1.5. It is very big number is coming, correct? Okay, in terms of seconds only you can keep it also, no problem. If you keep it 5 seconds, let me keep it 5 seconds only, no problem. Divided by 0.0000, what is this one? 0.015. 0.015 seconds. What is the simplified value? Simplified value? Triple six, total 666 you are telling, okay. Yes, efficiency is nothing but now. So this 7 by 666 only, na? Correct only, na? This is correct, JP? Pardasarathi? This expression is correct, Okay, just a minute, just going back. So 1, 2, I have to shift it where it 1, 2 times happen. This value is 0.0015 seconds, correct. Now still you can tell this value is JP. Okay, 667, okay, approximately if you take transmission delay, then this value is how much is coming now? Because network rate is very high, correct or not? 700 by why 700? JP, why 700 here? Okay, this value you got right, okay. This is full capacity. We are sending window size. Are they given any window size here? GBN protocol with no packet, find the maximum window size. Window size only they are asking, used full capacity. Out of full capacity we are sending N, correct? Okay, we have to only substitute this expression only, right? This expression only we need to substitute. Transmission delay, this value, it taking it what 100%, correct? Maximum window size channel at full capacity, correct? Yes. Sorry, I met here, right? Just a minute. So what is the maximum channel utilization if the protocol used above this one? The sequence number field is given 3 bit. Sequence number bit given, sir, 100% multiply. Achha, you substituted in this equation. Okay, after this, otherwise 7 by that value only you can do it, because you are able to utilize 3 bit, which means total available sequence number will be 8. GBN uses what? 7, correct or not? 7 by 667 we can write it, correct only, correct. So either you take 100 if you take in that value, or you can take in this value will be what you can say, this I can remove it. Here is simply you are saying that now efficiency equal to the 700 out of 667, correct, into 100%. So I hope it is a less than, so this less than 1% or approximately we can say 1%, approximately what 1%. Yes, that's 0.1, 0.10 only, even less than. So in terms of, if I want to express it, maximum what it can go up to 1%, even less only. So this way we can answer it. Okay. Now see next question. So which of the following is true about these protocols? Just think and answer it. This, what are the statements are right now? As previous question, like just please understand, based on these values only, based on just considering 10 power 3 only happen. If 10 power 8 is there, this definitely less, even increases. So better purely less than of this 1% you can write it, right. So which of the following is are true? GBN has high bandwidth uses than SR protocol, and SR protocol has higher CPU usage. GBN uses independent ACK, SR uses cumulative ACK. GBN protocol has a least CPU usage. Least CPU usage. What are the statements are right? Think. GBN has higher bandwidth uses than SR protocol. Higher bandwidth. The bandwidth consumption for what? Each packet is lost what? Entire window need to be transferred, correct? JP and other people. Suppose one packet is lost in GBN protocol, what should I do? We'll wait for timeout time. Again we'll send the entire what? Window, correct or not? Entire window we send it, right? So it is consumed. In case of SR protocol, only selected, like only the packet which is lost, that is where we are going to send it, correct or not? This is true. SR protocol has higher CPU usage. This also true. Why, sir? This also true. Why, sir? SR protocol uses the CPU utilization more. Why, sir? Because is performing what? Sorting, searching algorithms, correct or not? Searching, sorting required. That's why CPU utilization more. That is also true. GBN uses independent ACK, SR protocol uses cumulative. Is it true? Option C is true. Does option C is true? Yes, JP, we are right, you are right. Option C is incorrect or not? GBN uses what? Cumulative. GBN uses a cumulative, please understand. GBN uses a cumulative and SR uses what? Independent ACK. So therefore it is incorrect. GBN protocol has least CPU usage. No, there is a stop and wait protocol also there, correct or not? This is a least, efficiency is very less. Stop and wait protocol efficiency very less. Therefore this is false. This is false, right? So A, B are true statement. So I hope it is clear. Do you have any doubt on this one, ma? Anybody having any doubt? Correct, JP, correct. You are right. Chalo, move on to next part. Now coming into the error control method, error detection majorly you study CRC as checksum, and error correction Hamming codes we have to observe. The few things related to this one, we will see some questions. The message is to be required to transmitted using CRC polynomial function given. To protect it from error, the message that should be transmitted is dash. Can you solve it? Try to solve this question quickly. Solve this question, ma. So in this one, you have to generate what? CRC generator, you should take it, right? CRC generator. CRC generator. What is CRC generator? 1, this 0, 1, 1. Correct or not? CRC generator is what? Degree of polynomial plus 1. Correct or not? Degree of polynomial plus 1 is a CRC generator. So now what is the degree of polynomial is? That was the redundant data we should add it. Correct? Message what? 10, 110, 10, 111. Okay. For this less than 1, 3 zeros you should, redundant data you should add it. Redundant data we should add it. Correct? Or else you see the degree of polynomial, those many bits you add it, and this value is nothing but check bits, CRC bits only, na? This is CRC bits. Correct or not? This CRC bits we need to calculate. This CRC bits we need to send, right? Yes or no? Then calculate. So what is given? 10110, 10110, 10110, 10111, 10111. For this we added zeros. Correct? Zeros. Now we have to perform this division operation with a what you can say CRC generator, right? XOR operation we should perform it. So 1011, right? This value is 0, 0, 0, 0. Correct or not? Left over I am writing 0, 1, 0, 111, 0, 0, 0. Correct? Plus XOR operation is. So let's check 1011. Correct only. Correct only. So 10110. Sorry, 1011 only. Right. So this value also 0, 0, 0, 0, 1, 0, 0, 0. Correct or not? Now again XOR operation 1011. This value is what? 0, 0, 1, 1. Right? Yes. Your CRC is what? 0, 1, 1 only? 0, 1, 1. Okay. 0, 1, 1. What is the message? 111, right? 10, 10, 110, 111. This is not there. Option eliminated. 1011, 01, 0111 followed by this 010 added. So 010 nothing but 011 we got. Option B or C, ma? I think C correct? C only, na? 111, 10110, 10111, 01 we got, 011. Yes, yes, correct, correct. Yes, yes, yes. Chalo, move on to next question. Now, to guarantee correction up to T bits error, the minimum Hamming distance in the block code must be dash. Can you tell me Hamming distance? What is the meaning of Hamming distance? What is the meaning of Hamming distance? Please understand. Hamming distance. Suppose example, I am sending a message like this, no, 00, 01, 10, 11 like this message I am sending. Please observe now. Generally this message which you transmit we have to divide into block code. So let's take, I am just block size I am dividing like this assumption now. So 0001 1011 blocks, correct or not? What we do, no, transmitting message always we encode, encoding into different codes. Different codes we have to encode it. So what I will do it, I will use this parity bit. Number of ones how many here? Number of ones 0. So therefore I am adding even number 0 only. 0 ones I am adding. Number of ones are 1 odd. So I have to make it 1. This is a redundant data. This we call redundant data. 10 number of ones are odd. So I am making even. Number of ones odd, even, so 0. This we call code words, ma'am. We are transmitting your message in the code words. This is the code word 1, 2, 3 like the 4 code words. We are sending code word only. How we are going to detect or correct it, if this code words has to, this also given to the receiver. If sending data is whatever data you send that matches to any one of the code word, the sending data is correct only. If the transmitting message if it is not matches to any code word, then something is wrong. Something is wrong, correct or not? So therefore what I am trying to say, What I am trying to say here, example I am sending 0000, okay, 00 I am sending now. Some 1 bit error occur assumption. This will reach us to what 001. So does 001 is there in this code word? Does 001 is there in this code word? Tell me. It is not there. So other than code word received now. So receiver will understand that, okay, something is wrong in this one. So the transmitted message is wrong. This is a detection. But correction is what? Correction something else. So now please understand, to detect. So aiming distance is nothing but number of bit difference only. Very good. Difference in the corresponding bits only. Number of bit difference also we can tell. Number of bits distance also can tell. So what I am trying to say, suppose example you are sending one data like this. Carefully observe. If it changes to some form assumption, this is the form changes assumption now. This is the code word, okay, code word, okay, this is a valid code word, So this is what valid code word, okay, valid code word, and it became what invalid code word, invalid. So there may be some one more if changes something, there may be some valid code word will be there now. Somewhere valid code word will be there, correct or not? Now see, this is a invalid, this is a valid one. Like this valid one will be there like this. Now distance is what? Here is one distance, here is one distance. So distance is 2. So valid code to next valid code distance is 2. So I can detect 1 bit error. I can detect what? 1 bit error only I can detect. 2 bit error I cannot detect with this distance. I need one more distance. This is a detection. But in case of correction, what happens? Correction, please understand. In case of correction, suppose I am sending some valid code assumption. This is a valid code. Okay. Careful observe all of you. This you are sending valid code word assumption. Okay. 1 bit is corrupted assumption. 1 bit is corrupted. So that you are moving to what? This is one invalid code. You are moving to what? Invalid code. Maybe there is a something like, please understand. There is maybe some valid code assumption now. In this case, 1 bit is corrupted. This also can become this one of the invalid code or not. Can I say like this? Suppose I am sending example 0 0 I am sending. It became what? It became, please understand, 0 1 assumption now. So there is a possibility. So like let's take situation 1 0 1 I am taking. 1 0, okay, 0 came assumption now. 1 0 came like this, correct or not? So I might have sent like 1 1 0 also, correct or not? 1 1 0, okay. Now transmitted message changed to this one, correct or this bit is corrupted. In this case, this bit is corrupted, right? Okay. This is a next valid code assumption. This is one valid code. 1 bit is corrupted, changes to this one. In this valid code, this bit is corrupted, changes to what? This code, correct or not? Correction will be, we have to identify exactly which bit is corrupted. Exactly which bit is corrupted, we have to identify that one. So now whenever next valid code changes to this one, so confusion is that whether this is a valid code or this is a valid code is a doubt, correct? Are you getting my point? One valid code I sent it, some bit is corrupted, changes to this one. Maybe the next valid code I sent it, maybe either this or this is changes to this one. When I want to guess it which bit is corrupted, so I am not able to see that whether this or this one, correct or not. So the distance is not sufficient. What I have to do, if I want to correct 1 bit error, suppose this is a valid code, if it changes to one invalid code, please understand, maybe next valid code is there. If 1 bit changes to what? This must be some different valid code. Different invalid code should have. This must be different invalid code. Therefore, suppose if it is changing to this one, please understand, if it is changing to this one, I can say which is closer, this is a closer. I can take this is the data which has sent it. If you suppose this, if the received data is closer to this one, I will take it this distance, I will calculate the received data distance. Whichever the minimum distance is there, that I can say either you send this or this, I can guess it. Minimum distance I will calculate. Now what is the distance required now? What is the minimum distance required now? What is the distance? 1, 2, 3. 3 distance. 3 bit distance I should have. To detect, to correct 1 bit error, 3. 2 bit error. 2 bit error if I want to do. required even more. That's with this generalization what I am trying to do it here. So if I want to detect the t bit error, 3 I have to calculate, So this is option I am going to take it. So 2 into 1 plus 1. So the 3 distance I should have. So similarly I am trying to say, suppose example, if I take here 2 bit error, nothing but suppose 1 bit is corrupted to change to what invalid code assumption. So 1 bit is corrupted, this is changes to what, one more invalid code assumption like this. Okay, this changes to this one. Maybe somewhere one valid code is there, 1 bit is changes, this becomes to one invalid code. One more bit is changes, corrupted, this changes to what different invalid code should have. So invalid code should not be a common. Invalid code should not be a common. So therefore distance if you see 1, 2, 3, 4, 5. To correcting 2 bit error 5 required. Therefore 2t plus 1. Can I generalize or not all of you? Can I generalize 2t plus 1? Now can you tell me to detect the error, what is the Hamming distance required? Not correction, detection I am asking. To detecting the error, what is minimum Hamming distance required? Detecting the error. Try to respond everyone. To detecting the error, I am not looking for correction. I am not looking for correction. A detailed study I am not taking here because we need to study this detection correction mechanism clearly you have to study. Just I am giving a glance only. Detailed discussion I am not doing because it required time. It is required time. You should know this is required. Now just now I told you one point so 1 bit year to year changes must be invalid code should be there. The distance if 1 bit is there, next valid code will be here. Valid code and valid code in between invalid code you should have. So distance is 2. 1 bit correction 1 plus 1, 2 bit 2 plus 1, 3 bit 3 bit 3 plus 1. So t plus 1 I can generalize it. Detection very simple. T bit error can be detected t plus 1. Correction will be 2t plus 1. You should understand. Correction means we are going to exactly will tell what data transmission done. So that way you are able to answer it. Now can you find the minimum Hamming distance of the code scheme? They given 0, 0, 0 is a code 1 assumption. Code word to 0, 0, 0, 1, 1 given. Code 3, code word 3 is what 1, 0, 1 given. Code 4 is given 1, 1, 0, 1, 1, 0 given now. So what is the Hamming distance? Very simple Hamming distance value will be I am expressing this like C1 comma C2 is nothing but we have to do it what C1 XOR operation what C2, then find count the number of ones, so that is only your Hamming distance will get. So all Hamming distance you calculate, whatever minimum comes that is only your answer. To detect up to t bit error t plus 1 required, very good. So up to 2 t bit correction 2t plus 1 required, very good observation JP. Suppose now Hamming distance of C1 0, 0, 0 comma 0, 1, 1. So what is the XOR operation? This will be what you can say, this is first bit is 1, second bit going to be 0, third bit going to 0. Therefore distance is what 1. So Hamming distance of C1 C2. So like now if I take it C2 C1 C3 comma C3. So Hamming distance will be 0, 0, 0 comma so 1, 0, 1. So this equal to first bit is changed, second bit is same, third bit is changed. Therefore 2, distance is what 2. So find the minimum Hamming distance. Can I say answer is 1 only? Can I say answer is what 1? Am I right? The bit is same, second bit is okay, sorry, the bit is same is 0, 1, 1. This became 2. This became 2. Similarly we verify C1 to C2 C3 like this, verify it. Next C2 to C3 C2 to C4, now C3 to C4 like this we verify. Minimum all combinations, very good. Tell me the answer. What is the minimum Hamming distance? Minimum Hamming distance 2. So now minimum having distance 2 nothing but this code will able to detect how many bit error? 1 bit error only, right? Minimum having distance is 2 nothing but is able to detect how many bit error? 1 bit error only detection now. Now my question to you, if I want to correct 1 bit error, what is the minimum having distance required between any valid codes? If I want to correct 1 bit error, what is the minimum having distance required? Minimum having distance. I repeat my statement. What is the minimum having distance I should have to correct 1 bit error? To correct 1 bit error. Very good, 3. Yes, 3. Now coming into the next topic. So land technologies will see. Hamad, it is not 2, it should be 3. Minimum having distance required to correcting the 1 bit error will be 3. To detection, very good, very good, very good. That is clear. That is clear now. So here majorly we have to focus on some access control method, random access control methods we have Aloha, CSMA, CSMA CD and token passing. Then we have to see throughput of the channels, collision detection, efficiency of this one we have studied also. In a LAN environment, especially technology, Ethernet and token ring, you have to focus that like Ethernet frame format, token ring frame format, efficiency of token ring in terms of early token reinsertion, delayed token reinsertion. These are the things need to be focused. These are the things need to be focused. I hope this is clear. Is it clear all of you? Come to the point, consider 20 megabits Ethernet having 56 bit jamming signal, the propagation delay is 58. Find the minimum frame size in bits they are asking. Yes. I am taking 58, this unit is required microseconds now. Propagation delay is microsecond. Find the minimum frame size. So minimum frame size on Ethernet we know L must be greater than or equal to 2 times of propagation delay plus transmission delay of jam signal into what? Bandwidth, correct? This is going to be detect the what? Collision, correct? To detect the collision in Ethernet, minimum frame size must be greater than or equal to 2 times of propagation delay plus transmission delay of jam signal into bandwidth, correct? So now L is 2 times of propagation delay into 58 microseconds plus transmission delay. So transmission delay of jam signal, Ethernet having 56, so 56 bit divided by 20 into 10 power of 6 bits per second is there. This transmission delay will be 56 by 20 microseconds. So 56 by 20 microseconds into bandwidth is what? 20 into 10 power of 6 bits per second. Tell me what is the value, simplify and tell me. Everyone. Quickly answer this question. Simplify. 2376 bits. (297 bytes). 2376 bits. So in terms of bits only we are looking. Very good. All of you got same? I hope this you know, right? Everyone. I hope this you know. So come to the point, next question. Which of the following option is are true? CSMA CD should be used when the transmitter and receiver cannot be turned on simultaneously. Is it true? Statement A is true. CSMA CD should be used when the transmitter and receiver cannot be turned on simultaneously. Option A, is it true about CSMA CD? Carrier sends multiple access, multiple people can simultaneously sense, correct or not? Collision will happen, you have to detect, correct or not? CSM itself saying na, carrier is sensed by multiple access people. More than one people can try simultaneously. She is saying that we should not try it. Is it wrong or not? CSMA CD can have less collision probability than Aloha. Is it true? So Aloha comes into two types. One is pure Aloha, correct? Second one is slotted Aloha. Slotted Aloha. Correct. So what is the answer? CSMA CD have less collision probability than Aloha. In case of Aloha, there is no point of collision detection, correct or not? Every time collision can happen, right? Every time people, when they tried it, collision can occur or not? So CSMA CD have less collision probability than that of Aloha. The statement B is true or false? So CSMA CD collision rate is high or less? Collision rate in CSMA CD less only, please understand, this is true. That's what detection is telling now. We are detecting, they are stopping, correct or not? When collision is occur, we are detecting stopping by applying what? Again we are waiting, immediately we are not transmitting, correct? We are applying backup algorithm. Isn't it? It is reducing what? Probability rate of what? Error. Collision rate reducing. This true statement. Slotted Aloha does not sense the medium before sending a data. Is it true? Slotted Aloha does not sense a medium before sending a data. Does option C is true? Very good, JB, very good, JB. This also true. Aloha, CSMA, this all random, even CSMA CD also random access protocol, but only detection we have, only detection as a. In case of Aloha, please understand, there is no such mechanism sensing. Station can transmit whenever you wish, any station, any number of station can start transmitting. Collision highly possible, please understand, highly possible here. So there is no mechanism sensing here, there is no mechanism sensing in case of slotted Aloha. A node can start transmitting a data only at the beginning of the slot in a slotted Aloha. Is it true? A node can start transmitting the data only at the beginning of the slotted Aloha. In case, very good. No, CSMA we don't have detection, please understand. CSMA we don't have. CSMA CD we have. D also true. D also true. Some points please understand. If I talk about Aloha, please understand. Aloha comes into two flavors, correct or not? One is a pure Aloha. Second is what? Slotted Aloha. It is a purely random access protocol. Random access. Any station can transmit the data. And both the cases, please, data size is same. Data size is same for each station. Correct or not? Data size is same for each station. So now when it comes up to pure Aloha, please understand, Very simple. Any station want to send a data, you send it. Simply send it. So send, wait for acknowledgement. If you are getting acknowledgement, again you can initiate one more. If you are not getting acknowledgement, you have to wait what till timeout time. Timeout time nothing but 2 times of propagation delay, correct or not? Wait for timeout time, again retransmit it. That is what pure aloha concept, correct? Yes or no? Now in this case, please understand, vulnerable time for collision will be 2 times of frame transmission. 2 times of frame transmission. Vulnerable time for collision collision period also can tell. This is a collision period we can tell. The rate bandwidth, like let me also draw. What I'm sending data assumption now. One station is there. Let's take some more station also there, like the station A, station B, like station C is there. Okay, station C. Now some frame is there. Okay. What I told you, every station has what frame size same only. Transmission delay also same, correct? Yes or no? Transmission delay will be same for each station, right? Now situation understand, B is there, B started transmitting, okay. This is the what frame transmission time. This is a transmission of the frame assumption now. Frame transmission time, this one is there, B started. Suppose A started little early, little late started. This is going to overlap here or not? Yes or no? This is going to overlap or not? This is a frame transmission, frame transmitting here. Somewhere started like this. Now suppose C started little early assumption, little early started. Little early started. Okay. So as per this, little early started. Now see, collision is present or not? Here is a collision, right? Collision. Here is a collision or not? Collision. For this station to transmit, you should know about this time as well as this time. That's what 2 times of frame transmission is there. This is a area in which collision can occur. Collision period time you can tell this one. Am I right, all of you? Vulnerable time for occurring the collision will be 2 times of frame transmission time. And also you understand throughput. So throughput formula very important in case of pure aloha. So throughput, okay, throughput equal to, so G into e power of minus 2G, okay, because we generalize this one, what is the throughput can be achievable in case of pure aloha, G into e power of minus 2 minus G. What is G indication? What is G? Average number of packet transmitted by the stations. Very good GB, very good GB, okay. What is the G indication? Average number of packet transmitted by the station. What is the maximum throughput? If I suppose I want to maximize the throughput, if I want to maximize throughput, what should I do? I have to differentiate with respect to what? What you can say? Sir, G is the number of generated in one frame transmission time. Yes, exactly, one frame transmission time. Number of frames generated by the stations in one frame transmission delay, correct or not? Because when I am sending, many people is also trying, correct or not? Many packets are transmitted in this moment. Okay. So maximum throughput after differentiating with respect to what this G, definitely we are getting how many packets we are getting? So how many? What is the 18% only, right? You are right, 18%, 18.4 only percentage will get it. That is true. That is true. Okay. So this information about what you can say pure aloha. In case of slotted aloha, what we did, entire frame time, like time is divided into slots. Any station want to transmit the data, they has to attempt in the beginning of the slot only. Any slot you can be, in any slot you can transfer the data, but beginning of the slot only you should try it. The station has to start the transmit data beginning of the slot only. If any station little late, like beginning of the slot not able to transmit, you should not send it. You have to wait for next slot only. Therefore, vulnerable time for occurring collision will be one frame delay only. 1 frame delay only. For this throughput, what throughput expression for this one ma? What is the throughput expression for slotted aloha equal to what? So G into e power minus G only. So in this case doubled, throughput going to increase, right? Yes or no? It will be doubled. It will be doubled. Efficiency increase, throughput is increased here. So these are the informations can be observed. with this pure aloha, slotted aloha. Some questions I think added, we will observe it later. So, look this question and answer it. Look this question. Consider source A, destination B and router R. For sending a packet from source to destination, which of the following field will change at router R? Router R is there, what are the fields will change? Destination MAC of the packet will not be changed. Destination MAC of the destination MAC address of the destination MAC address, this one of the packet will not change. Destination MAC will be updated to MAC of B, and the source MAC will be also updated. Destination IP will be changed at router R. Source IP will change to IP of R. What are the fields will change? Very good, JP. You studied well. Now, what are the destination MAC of the packet will not be changed. So, destination MAC will change, correct or not? So, this is incorrect. So, destination MAC will be updated to MAC of B. B is nothing but destination only. Also, source MAC also will updated to what? Router R1 or router R. This is true. Destination IP will change at router R. So, will not change. Source will change at IP of R. This also will not change. We are not touching IP addresses, correct or not? Very good. So, only one possible, option B is right. So, these are the points can be observed. Now, come to the point here. In pure aloha network, transmit 200 bits on a shared channel of the 200 kilobits per second bandwidth is there. What is the effective number of frames successfully transferred, like this asking? In every 1000 frame produced by the system, if it is produces 1000 frames per second, if 1000 frames per seconds are generated by the stage network, now what the question is that what is the effective number of frames can be transmitted? That's what maximum throughput only they are asking, correct? Can you answer it? So, you know the formula also. So, maximum throughput for one frame delay value, correct or not? So, G into e power minus 2G, correct or not? G into 2 power minus 2G, okay. In one frame time, that's in a one frame time. So, this is a maximum throughput can be generated, correct or not? Then what is that value? How many frames successfully can transfer out of 1 second? How many they are sending? 1000 frames they are sending now. They are sending 1000 frames. Answer it, ma. Answer it. Now, understand the situation is that 1 second. 1 second you are able to send what 1000 frames you are sending, correct? 1000 frames. Now, aloha network transmit 2000 bits on a shared channel, 200 kilobits per second is there. What is the transmission delay? Transmission delay, can you get it? 200 bits. 200 bits by what? 200 into 10 power of 3 bits per second. So, bits cancel, 200 cancel, 1 millisecond we got. This one frame delay is what? 1 millisecond, right? 1 second 1000 frames are sent, in our transmission delay how many we will get? That is only point, correct or not? One frame delay we got 1 millisecond, very good. So, I am trying to answer it, very simple. 1 second you are able to send it 1000 frames, okay, 1000 frames. 1 millisecond, how many frames you are sending, correct? 1 into this value will be what? So, 1 frame only, correct? 1 frame only. This is nothing but your G value, correct? This is only G value or not? Average number of frames sent in a 1 frame delay is what? 1 only. Therefore, so maximum throughput, so throughput will be what? So, G into e power minus 2G. This is nothing but 1 into 2 power minus G, correct or not? This value how much is coming now? Can you calculate this one? 1 by 2 power of sorry, this is E, sorry. 1 by E value. What is 1 by E value? That is it 0.184 only? No, I think a different value. Check, calculate. What is this value? But this is 2 only, sorry. This is 2 only, 1 by E square only, right? So 0.189, very good. So now 0.189 maximum throughput which you can get it, right? So now number of frames transmitted, number of effective number of frames transmitted, this 1000 into what? 0.189, correct? I hope this is correct. This, any changes are there? Sorry, 0.1353. JP, check JP. JP, are you sure 0.189? Or is it 0.135? One by E square ma. 1 by E square value. So 0.135 ma. I think JP need to check. 0.135. So this is 0.135. So 135 frames I can send. That's the answer. Yes, correct. 135 only. So this way you can calculate. Similarly, in the case of slotted aloha, transmitting this one shared channel with 200 kilobits per second bandwidth, find the throughput if the system produces 500 frames per second. Tell me. So what is the throughput expression? In case of slotted aloha, it will be, so G into e power minus G only. Now see, 500 frames are generated per second, correct or not? So 500 frames generated 1 second. Now simply here also 1 millisecond only we are getting, right? 1 millisecond, how many frames are generated now? 1 millisecond, how many frames are generated? That is only question, correct? So this G, this is nothing but G value only now, 1 by 2. Is it 1 by 2? Hello? Then, so are you sure previous question JP 0.189 only? Because one other person is telling 0.135. Hamad, are you confirmed 0.135 only? Which one is right? Because you can use the calculator, right? So yes, E value 2.3 something correct only. When you take in 2.3, okay ma, so I am just giving you, so all of you, this based on this values only you calculate, you get the E values, like I am not telling 135 or maybe 189, you just check this, calculate the value and get it done. Here G is what 1 by 2 you are getting, correct or not? G is 1 by 2. So now what is throughput will possible now? So throughput equal to 1 by 2 into e power of minus 1 by 2, correct? Isn't it? What is this value is getting now? Yes, JP. What is this value you are getting? calculate. Here is 0.3032. So 0.3032. Okay. So now maximum throughput. So maximum throughput is possible is what? 500 frames into 0.032. Correct? 32.9%. So now you have to multiply 500 only. Correct? Then answer must be Parthasarathi, what is your answer? Calculate fast. So 164 frames. 164 frames. Okay, fine. Now, can you answer this question, ma? Node X and Y are connected over a channel with a propagation delay of 15 millisecond, and X and Y started transmitting at time t equal to 2 millisecond. Frames are collide. After the first collision, X win the collision. Ignore the jam signal. Given bandwidth of the channel is 20 megabits per second. Size of the frame is 1000 bits. At what time A's packet is fully delivered to B in seconds? Try. A CSMA CD. It is based on CSMA CD. It is based on the CSMA CD. Try this question. Okay, Hamad, that's what JP I'm asking you, both of you, like you just use proper E-value. Based on the E-value only answer will change. So other people, those who are going to check later also check, use the E-value properly. Based on E-value only calculate it. So 24.5. Let's solve this question. Let's solve this question. Now I am taking this bus topology. Suppose station X is there, station Y is there. Propagation delay is what, 15 seconds. Propagation delay is 15 milliseconds given. 15 milliseconds, correct. Then X and Y transmitting at 2 milliseconds. Okay. At time t equal to 2 milliseconds, it is time t equal to 2 milliseconds started transmitting, correct or not? Okay. At time t equal to 2 milliseconds at this one, correct or not? Now at time, you understand, 2 milliseconds plus 15 by 2 milliseconds, correct? At time t equal to 2 milliseconds plus 15 by 2 milliseconds, so collision happen, correct? Yes or no? Collision happens or not now? Collision happens, right? Collision happen now. So purging time we are not using, that's what jam signal time is not added here. Okay, now see, collision happen now. Then 2 times of this 2 milliseconds plus, it will get propagate, signal, collision signal will propagate, transmission delay is ignored here. Jam signal transmission delay is what ignored here. So now 15 by 2 milliseconds plus half time, 15 by 2 milliseconds. Here also time t equal to 2 milliseconds plus 15 by 2 milliseconds plus 15 by 2 milliseconds. So they came to know collision. Very simply this value I can write it at 17 milliseconds they come to know, correct? Both they come to know 17 milliseconds. Any doubt is there? Anybody having a doubt here? At 17th millisecond they come to know, yes, the collision occur, then they stop transmitting. Am I right or not? Am I right or not? Now they applied what? Backup algorithm. X has won the chance, he will successfully transmit it, correct or not? So one more thing you should notice here, at time t equal to 17 plus 15 milliseconds, that means at time t equal to 32 millisecond, okay, X will start transmitting the packet, start the transmission. Why, sir, why you are considering again this 15 millisecond? Please understand, once collision is happened, to clear that one, to clear this signal, we have to wait for one propagation delay. Maybe any signals are there that can be removed, it can be gone. Are you getting my point? That's the reason we have to wait for one propagation delay. Actually by frame transmission happen what? At 32 millisecond now. So at time t equal to 32 milliseconds plus transmission delay, can you calculate what is transmission delay? So transmission delay of a packet, channel bandwidth 20 megabits per second, frame size is what? 1000 bits. 1000 bits divided by 20 into 10 power 6 bits per second, right? So this value will be 0 cancel, 50 microseconds. 50 microsecond is nothing but, so what should I write it? 50 microseconds only. Am I right of 50 microseconds, others are in milliseconds. Now 0.05, correct, tell me now what is the transmission delay? Transmission delay 0.05 milliseconds, okay. Now 0.05 milliseconds transmission, propagation is what? 15 milliseconds, propagate it. At time t, 32 plus 15, 47.05 millisecond. So packet successfully reached or not? Am I right, all of you? Yes, JP, Hamad, Parthasarathi, 47.05 milliseconds. Very good. This way you should observe it. If suppose if jam signal is there, jam transmission delay I should consider, correct or not? Is there in this case? Now 2 milliseconds plus this collision happened plus transmission time of jam signal you should consider. Transmission time of jam signal plus propagation, this one, because when signal happen like collision happen, the jam signal will come, right, somebody will produce, that you would consider. If they given, not given, I fine. So this way you should answer it now, this way we should answer it. I hope this is clear. So next we will look into switching, especially in this one, now packet switching only. So packet switching will observe it, okay. So I'll try to take this session, this part into one more session, because we need to see IP addressing, like on IP header format, fragmentation and routing and TCP, UDP as well as application layer protocols we have. So I would like to take one more sessions on computer networks. So that will plan tomorrow, that is 27th this December, you will be having a DBMS, I think DBMS is there. Tomorrow is what DBMS will be there, and Saturday I will be planning 27th of December part 2. Computer networks part 2 I am going to plan it. So try to again check it and revise the things, especially like algorithms, routing algorithm, TCP like wrap around time, congestion control, error control things. Try to revise so that with this question one more time revision we do, we'll observe all important points. So definitely computer network subject syllabus is more, but if you study more times, if you solve it, more number of questions, more revision you do, so most of the questions are solvable. In the last year our all students, now 9 out of 9 questions they have solved it. 9 marks came from computer network each section. So last year 2024 gate was happened into 2 sessions. In a 2 sessions 9 marks came from our computer networks. A very important subject. My dear all students, don't neglect the computer networks topics. The topics which I mentioned, try to cover it, because they may come 1 mark question or 2 mark questions are possible. Okay, fine. I would like to stop this session. Anybody having any queries? Anybody have a query? JP, Hamad and other people. I hope this session is really helping you to revise the most important topic through problem solving. Okay, we'll continue to part 2. So those who are going to watch are like not able to watch this session. What I'm trying to say, so we have conducted the session operating system, computer architecture, and this also then many subjects we are planning upcoming days. So try to utilize these sessions. It will really help you a lot to revise the things, and some confusion areas will be there. Example, Hamad and JP, you understand. One thing we get confusion, especially sliding window protocol, the sequence number bits were there, right? Correct or not? So available sequence number we consider for sliding window protocol, because that is you have to take as it is only. That's what full capacity I can send it, correct or not? Because we have seen the network configuration, propagation delay, transmission, how many packets we are able to send it, that means sequence number required or not. JP just giving the clarification on that part. So transmission delay, propagation delay, round trip time if you calculate, the total data divided packet size, those many packets you are able to send it. You are able to send that many packets, nothing, those many sequence number required or not. That is itself sliding window protocol. Sliding window protocol fully uses all the sequence numbers. But there is a problem, can create a duplicate packets at receiver end. To control this one, we are adjusting this window sizes. That adjustment window size is nothing but GBN and SR protocols only. So like this, some areas will be there. When you discuss this thing, definitely is going to be clarified. So I hope this session is really help you. So we'll continue part 2 into next session. Thank you all. Thank you so much.